noting that our primary objective will be a practical one, taking the mindset of an engineer or possibly a bookkeeper trying to put an engine or set of books together today, looking to the past, hoping to glean some information about the process that would help us put the thing together today. That does not mean, however, that we're just going to accept dogmatically the series of steps taken in the past to put the thing together. It does mean that if we make any changes to that series of steps, we have to make the argument. In other words, like in a court of law, saying you're innocent until proven guilty, similarly here, the process is the best process. It worked unless proven otherwise. You have to have a preponderance of evidence showing why you would be doing something different. That's the perspective we'd like to take here. All right, the historical foundations and practical logic. Music theory is a product of both mathematical discovery and practical adoption. So to apply it effectively, it's useful to understand why it developed as it did. That is our objective. I'm going to use an analogy here. It's not going to be a perfect analogy, but it gets the idea, the mindset that we want in our mind. So we're the modern engineer over here. We're trying to put together an engine. Let's imagine we're thinking back to the Model T or something like that to see how that was put together so that we can get an idea of how to put together the modern engine. Let's imagine, and this is fiction, this is a fictional story to get the idea or mindset, that as the Model T was being put together, it was put together in an order that was defined in part by the parts that were available. And the parts were being shipped in from wherever they're being shipped in. We're imagining like China or something like that, right? So you're imagining that they're putting the engine together not in the most efficient process possibly, but as the parts are arising. So if we're over here and we're saying, hey, look, I got all the parts on the table. I don't really, is there a different order that I might put the engine together in now that I have all the parts on the table? Or should I dogmatically just take the same series of steps that happened when they put the Model T together in my fictional story on how it was put together, right? And I think most people would say, hey, look, I'm trying to get the engine together as efficiently as I can to understand it as best I can. I can make a solid argument as to why, if I already have the parts on the table, I should do it in a different order. I should line it up differently. I'm going to put it together in a different order. That's a kind of similarity to the argument that we're going to be making on a historical basis. I accept that the Model T engine worked. I accept that it was a genius invention. But I'm not going to dogmatically follow the same steps if there's a rational reason not to do so, unless I'm putting something together that's a historical thing rather than an innovation or something that's functional. All right, and music does have a function, right? I need to learn it. I need to understand it so that I can then create it. And the functional practice then is to understand the elements so that I can then play with it and create it. Now you can see this most clearly in our most revered instrument, that being the piano. The piano is, so I'm gonna say some things about the piano that could upset people, but I want to lay down the foundation here and just say, obviously the piano is the baseline instrument. It's the keyboard that's going to be used even in today in modern technologies and DOSes and whatnot when you put things in electronically, and that's because in part you have one key that you can play in, and then you can transpose that key. And of course you can play with two hands, which means you can play the melody and you can play something else, chords at the same time. So functionally, great instrument. But you can kind of see historically, and we'll get into this more after we look at the historical building, that it was put together kind of like how the pieces came in our analogy, meaning how the historical pieces were gleaned, how the knowledges came up, kind of dictates how the piano looks like it was built. In other words, we came up with the 7 notes first and then kind of crammed in the 12 notes. Why did it happen that way? And once we come up to why did it happen that way, I will come back to the question of, would you redesign the piano if you had all the parts on the table? I think there's a strong argument for no, even from a functional basis. But you could imagine different structures of the piano. I know that's kind of sacrilege to say here, but I'm just saying, just for a thought experiment, we'll put that on. We'll come back to it. Let's go through the history, and then we'll come back to that idea at the end. All right, so we have to go back to good old Pythagoras and the birth of the musical ratios. Now, Pythagoras didn't have a lute, I don't believe. He was playing like with one string to try to figure out the ratios and whatnot. But this is just a picture from AI to get us an idea. He's an ancient Greek guy. So Pythagoras and his school, circa 500 BC, that sounds for before Christ, around here at least. That's what we call it, before Christ. They discovered the simple string length ratios created harmonies and sound. So he's the one that did some experiments. And of course, the Greek guys, so this is 500 BC, right? That's way back there. And you can think of the ideas of like Plato in his cave and whatnot, gave us a lot of the ideas that we still kind of grapple with today. And one of those ideas is that there's certain things that are going to be more real than most of the things that we actually see physically, such as the envisionment of a triangle is more real in some ways than an actual written triangle, because a written triangle is not perfect, right? It's drawn imperfectly, even if drawn by a computer, whereas the concept of the triangle is more real. And you can see if you apply that school of thought out, you can imagine, well, then things like formulas become more real, math becomes something that describes reality in a more precise way than the imprecise way that we actually see math being portrayed in reality. And music, he's going to see kind of as ratios, as a form of kind of math, right? So he figured out that the octave has a 2-1, the perfect fifth has a 3-2, and the perfect fourth has a 4-3. So how did he do this? You can imagine one string that he was plucking and said, well, what if I made half the string? What if I made a fourth of the string, and so on and so forth? And he was doing these experiments, and he came out with these ratios, which at the time, as far as I can tell, was quite profound to them. So the school of Pythagoras became, a very important, thought tank, I guess, is a way that you can think of it. And they revered, numbers, and they revered music because of its number quality. I point this out too because I think that these days we've kind of lost that to some degree. We think of it as so aesthetic that saying that it has to do with math is almost an insult to it, which is totally opposite to obviously the creation of it, where Pythagoras was like, it is math. It's math in ears. It's math in like math alive. That's why the whole school was like, this is the fun. Music is the fundamental thing. Why? Because it is math, right? That's why. So that's why the Greek people, I think, were saying, look, kids should be learning music from the grade school, like as kids, because it's ratios, because it's math, because it's basically the underpinnings of reality. And these days, I think we kind of lost that, in part possibly because we lost the numbers. So most people don't really know what the number system mean. We use letters, which kind of takes us, which is fine, but it takes us like a step removed from the real idea that you kind of could grasp from it, which is the ratios. In any case, these intervals were derived by dividing a vibrating string and observing the pitch production. So their theory, harmony is math. Beautiful intervals come from simple ratios. So you can see what happened. He didn't have 12 equal notes within an octave. He had one string, plucking it and saying, oh my goodness, this is cool because these ratios come up to the musical harmonies that are pleasing to our ears, have these beautiful ratios that are working out, which fits perfectly into my Platonic idea of math being, the real underpinning of reality, right? Now, as we go in our story, we also have to just deal with the idea of this. Is it cultural? Is music completely cultural, or is it completely scientific as we deconstruct the engine here? And of course, it's a mix between the two of them. There are, of course, cultural components, but there's going to be some things that you would think all cultures would kind of unify in because there's a scientific underpinning. We talked a little bit about that last time in a harmonic series we've discussed before, which we'll touch on here. And you can see that if any culture started to pluck a string, they're probably going to find the same pitches that are going to be pleasing to the ear. So the idea for Pythagoras is that's a human thing. That's what all cultures you would think they would come to some degree, although there could be variations in different cultures, which we'll talk more a little bit about later. Just want to touch on that idea here. Also note that he discovered that the octave is the range that you can work in. So you can't really, no culture is going to come up with different pitches through the octaves. Why? Because that would mean that men and women couldn't sing together because they typically have different pitches in their voices. So if you do not have symmetry past the octave, then it would be a horrible thing for most cultures, because then men and women couldn't sing together, you would think. So once again, just the way it works, you would think, would mean that there are certain boundaries that a culture would have to pick from. One would be you're going to pick a series of pitches that are between an octave and that are going to repeat. And then the question, and then you would think some would be tied out to the harmonic series, which would have some similarities. And then you have a range of differences within that range to pick pitches that you might choose culturally, right?